we will get started. So hey everyone, today I'm Lu, and today I will have present with my co-speaker Alison here. So we will give a talk about how we empowering PySpark with Lens AI data lake for multimodal AI data pipeline. And I'm the database engineer at LanceDB. So I'm basically building like big data and AI frameworks. Of course, Lens and Alacio, Ray, and Spark. But my contribution is nothing compared to what Alisa has done. And she's one of the early members for PySpark and also Spark SQL. So he has been working hard to bridge like big data like Spark with all the Gen AI frameworks like Lens. And the problem that we are trying to solve today is how we're dealing with the multi-modal data. It's not just text, it's not just like small like tabular data. We are actually dealing with like images, PDF, like sensor data, video, audio, all kinds of like large data, basically large blobs. And also embedding is also large. The existing frameworks like the big data frameworks, they are short in dealing with those large blob data. And that's why we come up with the solution called Lens AI Data Lake. It's kind of like a Parquet plus Iceberg plus indices, but built for the AI from the day one. We try to use like Parquet and Iceberg in the beginning to solve the problems that we face in AI workloads. However, we shortly found that it's a heavy lifting for the Parquet and Iceberg. We have to do a bunch of like modification on top, but the performance is not meeting our expectation. That's why we try to build everything from the ground up. So the question that we're trying to serve is listed here. We sometimes call it the new cat theorem. So we want to be able to store multimodal data, basically the large blobs. And we want to be able to do really fast data access. And the two access the pattern that we basically identify that is common in AI workloads is first similar to Parquet, the fast scan performance. How can you quickly string a large block of data to your applications? And the second one is random access. Basically for AI workloads, especially for training, like you're doing open shuffling, and also for serving all kinds of different search. You need to be able to do all one random access to find the rows that you need, and then take that row to your application. And Parquet and Iceberg is short in dealing with the random access. That's why we are building everything from ground up to solve this problem. That support large blocks, support multimodal data, allow you to do fast scan that basically comparable to what Parquet can did, and solve the O1 random access, which Parquet is short in dealing with. And outside of this, we also want to support all kinds of indices to speed out our fast data access. And compared to Iceberg, we have many functions that Iceberg already existing, like doing the versioning, doing the schema evolution. But we are not just dealing with the old school like schema evolution. What we support is called functions. So you can take a column, and then you can define your own function of like how you're going to, what transformation you want to apply on top of that column to generate another column. So this function will apply to each value in that column. So you can really easily say that, oh, I want to like multiply by 2, or I want to like leverage some kind of models to generate the information out of the existing column as a new column. I will give like more details example in the later slides. Like AI companies, they are processing a large amount of images, especially for companies like Wordlet and Midjourney. Like Wordlet is founded by Fei Li, and it's the emerging leader in the 3D generation AI area. And Midjourney is one of the biggest like AI image generation company. For those companies, like images is a critical asset. How can you process a large amount of images, and how can you dig out information from those images are critical. And in this case, they store all their images, like billion of like images in LanceDB, in Lens AI Data Lake. And they use the functions to leverage the existing models to generate information like, oh, what this image is actually talking about. Are there two people fighting each other? Or what's the caption of this image? Like what they actually catch. And then you can also use some of the existing Python libraries to generate rich metadata from those images. Like what's the width, what's the height of these images. And all those information will be stored as different columns in a well-organized way in a single table. Another example here is about video processing. Like companies like Runway, which is the leading AI video generation company, they need to leverage their massive scale video assets and rich metadata to build their video foundation models. And they use LanceDB to efficiently store videos and the video metadata that generate here, leverage Lance functions. And from the videos, they can process images, also audio information. And all those can be stored as different tables inside Lance AI data lake. And from each table, from video, you can use the existing Python libraries to get pattern of the video, and also maybe a summary of what this video is actually about, like some test information. And you can also use embedding models to generate embeddings and generate all kinds of information from your original multimodal data. For images, you can also leverage models to generate what this image is actually about, what's the caption, and what's the embedding, and all kinds of information. So in this way, all your videos, images, and audio, together with all the information that you generate from the source data, can all store in the same Lance AI data lake. And if we have multimodal data just stored there and we're not using it, that is useless. But so for Lance, we're not just storing multimodal data. We actually allow you to do a rich search on top of your multimodal data. So here we support 3 kinds of different search capability. We support full text search, which is basically keyword search. Just like Google, you type your keyword and then you get your results. So it's really helpful when you turn your multimodal data into some text description, and then you search based on the keywords on these text columns. And we also support so for full text search, one example is if you have a kind of recipe kind of data lake, and you want to search of oh, I want to make an apple pie tonight, and then you can use keyword search to search apple and pie to get the recipes that basically do apple pie. Sometimes when you ask your other half of what do you feel like eating tonight? You may say, oh, I want something sweet but not that sweet, sour but not that sour. Then you may not be able to leverage full text search. That this is the moment that you kind of trying to leverage vector search. So to search the recipe that actually fulfill your really vague requirements. And you can combine these two together to search an apple recipe that is sweet but not that sweet, sour but not that sour. But then you may get some really creepy kind of a recipe that maybe they combine apple pie with salmon, with different kinds of fish, and then create something really weird. Then this is the moment that you want to leverage SQL search. You can search only the recipes that have reviews more than 100, and also the recipes that have 4 out of 5 reviews. Basically, the score is good. So in this case, you can leverage all the full text search, vector search, and SQL search to fulfill your search requirement, both for exactly match queries, for really vague queries, and also to do the filtering to make sure the search quality is good. And on the other hand, we provide the search engine, and the search engine is highly scalable. The scalable is coming from our architecture design. You store all the multimodal data on cloud storage, leverage Lance AI data lake. On the other side, you have the search engine. So search engine will only put the needed data and indices from the cloud storage into your compute cluster. So which is if you want more search capability, higher QPS, you just launch more compute engine. So that's pretty simple. Then because of that, we are able to support 2 different workloads. You can do the local experiment with just a Python library. You can just import import Python LanceDB, import LanceDB, and then you can do all kinds of experiment to create your multimodal data set, to do all these kind of searches. And we also have the massive scalable LanceDB cloud and enterprise offering, which can do a much bigger scale. For example, our biggest deployment currently is more than 10 billion rows, more than 20 petabytes of data. And we serve more than 20,000 QPS queries per second. And also we're serving a really fast speed under 150 milliseconds for P99. And all those can be used the same code. Basically, when you switch from local experiment to your enterprise, you just switch which endpoint you connect to. Is your local endpoint or is the cloud or enterprise endpoint? So the same code can be applied to the local experiment and also for your enterprise deployment. And I just talked about so many different functionalities that Lens already serve, but how does different pieces that merge together? And this is the graph that we merge all the capabilities together. In the traditional data lake on the left side, you may have your traditional data lake. You may have different kinds of database that for different functions. Like, for example, you may have the Elasticsearch to do full text search. You may leverage vector database for vector search, and you may have the PostgreSDB that allow you to do SQL search. Like each database have their basically their search capability. If you want to add another one, you need to add another data storage and a different framework. And on the other side, in order to basically provide a good data access capability for different data analytics and training framework, you also need to create your own training data lake or your warehouse solution to be able to connect to different big data and AI frameworks. But leverage Lens AI data lake, we are able to help you to store multimodal data directly in the data lake. And the data lake, the search engine that we already developed, can directly support you to do vector search, full text search, and SQL search, and the combination, random combination of those search capabilities. And on the other side, we are able to directly connect to the compute engine. And actually, the performance is pretty good because we are able to leverage the random access capability and all kinds of search capability that embedded in our search engine, so that we can do a bunch of query optimization that the traditional Parquet Iceberg cannot do. And so as I mentioned, Lens AI data lake could have a rich functionality, but we are not trying to solve everything by ourselves. We have a rich company ecosystem. So you can leverage Spark, Pandas, Arrow for data generation. So especially for Spark, you can quickly ingest your data from your data sources in a distributed way into this multimodal Lens AI data lake. And after your data is saved in the Lens AI data lake, you are able to analyze this data and to get information out of this data, leveraging Spark, Chino, and DB to do your SQL queries and to do your BI workloads. And you are able to use PyTorch and Ray to do training on the multimodal data. And this is exactly what companies like WordLab, Midjourney, Runway is doing. So all those data is stored in the data lake, and then we just funnel the data into our training workloads. And on the other side, we also support serving. So you can integrate with the current popular RAG or agent systems to do serving, using your familiar tools. Although LanceDB we support serving directly, but you can also integrate with those frameworks to leverage the bigger community. And later on, Alison will give a really zoom-in view of how Lens and Spark working together. And because of all those capabilities and the things that we are able to solve, so we are actually being used in production by the leading data infra company and also the frontier model companies, like Databricks, ByteDance, the several biggest data infra company, and also for the frontier model company, like the image foundation model company, the video, the 3D, and also the multimodal data access company, and also autonomous drive the companies. And also we are leveraging by the agent company. For example, Harvey is the biggest AI law firm company. Now I will hand it to Alison to talk more about how Lens and Spark work together.
All right. Okay, thanks Lou. Can everyone hear me? Okay, great, awesome. Okay, thanks Lou for the awesome introduction for LanceDB. I really like the recipe examples that Lou gave. That's just a very fascinating examples. Okay, so now let's talk about the challenge. So the challenge that we are facing today in the big data landscape is the disconnect between the big data and the AI applications. So on the left-hand side, we have the world of data. So here we're dealing with multimodal data, including text, images, audios, PDF files. And oftentimes, we need to process these multimodal data using analytics engines like Spark. and for data transformations and data cleanings and various use cases. So on the left-hand side, we have data, and on the right-hand side, we have AI. And efficient data formats like Lens can actually be used to power a variety of AI applications. But here's the problem. There's a gap between the data world and the AI world, and they don't really talk to each other seamlessly. You need to write your custom functions to convert a data frame into the Lens format or vice versa. So how can we bridge these two worlds together? And the solution here is the LanceSpark connector. The Spark provides multiple APIs for you to integrate different connectors into Spark. And the LanceDB recently added a new Spark Lens connector. And you can also use the new Python data source API to build your own connectors. So here is the LanceSpark connector, I think built by Jack from LanceDB. He's here. So it can seamlessly allow you to query the datasets stored in the Lens format in Spark to do all kinds of transformations. And it can also leverage a lot of performance features, for instance, the column pruning and the future pushdown for different, to make it more performant. However, this connector currently only works for reading from the Lens dataset. So what if you want to write a Spark data frame into the Lens format? Now introducing a new kind of API. It's called Python data source API. It allows you to actually build your custom connectors in Spark just in Python. So it's a new feature in Spark 4, and it can be seamlessly integrated into your existing pipelines, and it supports both batch processing and stream processing for both reading and writing the data. So there are three main steps for you to use and develop a connector for LanceDB. So first of all, you can extend the data source class, and you can give it a descriptive name like Lens. And then once you build your data sets, build your data source, you can register this data source into the current Spark session, and then be able to use your data source by leveraging the Spark's data frame API. So how it works under the hood, it's just in 3 lines of code, we can actually build a fully functional LanceDB Lens writer to convert a Spark data frame into the Lens format. And it's performant because it can leverage Apache Arrow under the hood. So Arrow actually minimizes the serialization overhead, enabling fast zero-copy data transfer between the JVM and the Python process. And it's also very simple. So you can use LanceDB's API and Spark's data frame API together, and it can be seamlessly integrated with Apache Arrow. And here's how you can easily use this connector. You can register this custom LanceSpark connector and write a data frame using the Lens format just in 1 line of code. So here are many other sessions in the DICE Summit. And we recommend you to watch and learn more about LanceDB and the Python data source API. Okay, that's all. Thank you for coming. And if you have any questions, feel free to find me and Lou.